Hello, welcome to A1 Tutor Live class. Now we're going to be having physics. Last class we are discussing a topic which we concluded last week. That was machine. We're talking about machine and we're able to discuss the type of machines. We're able to do some calculations that has to do with the mechanical advantage, the velocity ratio, the efficiency of a machine, and the last class. And we're able to divide the topic machine into three classes, part one, part two, and part three. So in case you were not chance to join the live class while we discuss the topic machine, you can still have access to the video, and that is on YouTube. So if you are not chance to be part of the class, do well to go to YouTube, search for A1 Tutor, and you're going to have the video machine part one, machine part two, and machine part three. Download it and watch it, or you can actually also watch it online from YouTube. Okay, and to make that very easy, I would suggest that you subscribe to the YouTube channel of A1 Tutor. So anytime you miss a class in the live session, you can do well to watch it on the YouTube. So you will get notifications of the videos. The videos will be uploaded on daily basis. So you'll be getting notifications of those videos. And that will be easier only if you can subscribe to the YouTube channel. Okay? It doesn't bite. Just click and you have your subscription done. Subscribe on the YouTube channel is free, no cost. Just to click a button and you have subscribed to the YouTube channel. You can as well also, while watching or after watching the YouTube videos of A1 Tutors, drop your comments in the comment section on YouTube. And if you have questions, drop your questions in the comment section. We'll definitely going to give you a response to those questions. Do well to like our videos and do well to share the link with your friends also. Okay, thank you. So today we are taking a new topic entirely. And if you are happy to hear that, please thumbs up. We are moving and we are progressing. We are taking a new topic today. Okay, thank you, Enoch, for your reaction. Like I said, we are taking a new topic. Now, for every topic, there's always a story behind it. All right? Yes, science is fun, actually, very fun. Science is fun. So, everything that we do in life has to do with science, even down to physics. So, is there anything that you're going to be discussing in physics that does not have its way in real life? No. Everything can be traced back to real life. Now, today, we are looking at the pictures that we have on the screen. You should be able to guess of the topic. So, who is going to help us out? If you are following us on YouTube, you can type the topic in the comment section. Online here, live class, who's going to tell us the topic we are treating today? Looking at these pictures. Looking at these pictures. What is the topic? Thank you, Enoch. That's awesome. Elastic, or we call it elasticity. Okay, we are talking about elastic today as a topic, but in the concept of physics. In the concept of what? Physics. We are talking about elasticity today in the concept of what? Physics. Now, everything we have here as pictures depicts an elastic materials. Starting from this, starting from this, what we have here, that's the air scrunchies used by ladies, is an elastic material because if you stretch it and you actually release it, it will come back to its position again. And that is one good property of an elastic. It can regain back its what original position. So the air scrunchies is an elastic. You stretch it, when you release it, it comes back to its what original position. The next one we have here is the elastic waistband. Yes, this is used by both men and women. Some of our trousers have a waistband, and that is why if you become more big, you can still wear it because it will keep stretching. Okay, and when you are out of the trouser, like you are not putting it on, it comes back to its normal position as if it's small. But when you put it on, it's still going to size you because it's going to stretch. Okay, it's going to stretch. It has a property of what? Elasticity. It has a property of what? Elasticity. Then we have the resistance band. That is what this young man is having here. This is a resistance band that we have here. So it's also an elastic. It's also an elastic. All right. Now, the one that is even common to everybody that all of us actually know is this rubber band. Yes. All of us, while we are still in school, or even those who are still in school presently, will make use of rubber band at our wristband here. And what do you use it for? You use it to actually look for trouble in the class. You stretch it and you what? You tap your friend with it. So that rubber band that you have been using to play jokingly in the class with your friends is also an elastic material. It's also an elastic material. So all these things are things we can relate with that talks about elastic. What is an elastic? Today we are talking about elasticity. Elasticity. So we want to look at what elastic is in the concept of physics. We are going to define it according to physics. We are going to consider the things we need to know about elastic in the aspect of what physics before we dive into calculation. I believe that is clear to us. If yes, please thumbs up. Now, before we start the class with explanation, I have a very trickish question for us and I want us to answer. Okay? Give me a few minutes. I'm going to show you a picture and take notes. I'm going to compare the picture, the rubber band, okay, with that picture. So I'm going to show you a picture right away now. Then you are going to tell me which of the two objects is more elastic. Which of the two objects is more elastic? I want you to tell me that. I'm going to show you the picture. Okay, so we have this. Yes, we have this is what? A steel spoon. Steel, a metal called steel. This is a steel spoon. A steel spoon. Now we are comparing the steel spoon against a rubber ball. Okay, a steel spoon and a rubber ball. A steel spoon is option 1 and the rubber ball is option 2. Now, which of the two is more elastic? That's the question. If you are following us on YouTube, I need your response in the comment section. This needs to be very interactive and educative. I'm not going to say anything yet, but if you have your response, drop it in the chat box. And for those people following us on YouTube, drop your response in the comment section. Between a steel spoon and a rubber ball, which one is more elastic? Which one is more elastic? Which one is more elastic? And you can give your reasons also while you are giving your comments on YouTube. And for we that are on live class also, I would like to have your response in the chat box. So this is the question I have for us. Now let's go to the class proper. Let's start the topic proper. I will attend to this question, but I want to have your ideas from you, and then I'm going to share light on this question. Okay, now let's proceed. Are we together? If yes, please signify. We are going to take the definition of elasticity. We are going to take the definition of elasticity. Yes, I've been receiving some response here. Somebody said the rubber ball is more elastic. Okay, we have accepted that response, but we still need more response before we now share the light to this. At the end of the video of the class today, I'm going to share the light to this question. So stay tuned to have the response to it. Okay, now let's go with the definition of elasticity. What is elasticity? According to the concept of physics, what is elasticity according to the concept of physics? I believe we are all together. If yes, please signify. Now, elasticity. The definition of elasticity is given as the ability, the ability of an object or material to resume its normal shape after being stretched or compressed. Okay? Elasticity is the ability of a material, okay, the ability of a material to regain its original shape or size after being stretched or compressed. After being stretched or compressed. So if you have a material or you have a solid that have the ability to be stretched or to be compressed and still retain its original shape or size, such solid material is said to be an elastic. Such solid material is said to be an elastic. Now look at this picture. We have a rubber band. When you stretch it, okay, it seems as if the length is increasing. But when you release one of your hands, you notice that it comes back to its original position. Okay. Now, what about compress now? Let's take a spring as an example. A spring. If I compress a spring, I'm going to have the original shape when I remove my hand. That is the force that is compressing it. When the force is no more present, that is, you have allowed it to attain back its original position. Let's look at that spring together. A spring, and that is what they actually use in cars. If you check the tire of a car, you're going to have a spring there. We call it absorber. Okay, that is the functionality of that thing there. It helps the car or the tire of a car to be able to bounce up, bounce down while you're even driving. Okay. Now a spring. Let's look at that spring. Okay, this. Let's look at this together. Now this is a spring. A spring has both ability to be stretched. A spring has both ability to be stretched. Now looking at this diagram, we are going to see that this is the normal length of the spring. Okay, but when an external body, which is a force in form of weights, was added to the spring stretched from the initial to the final length. Now, if I remove this object, which represents the weight, if I should remove it, it will go back to its normal length. It will go back to its normal length. So a spring is also a good example of an elastic. It can be stretched, it can be compressed, and it will still regain back its original position. Now, this is where you have to be very careful and listen attentively. When I was asking a question about a steel spoon and a rubber band, now which one is more elastic? Now, look at a spring. A spring is not a rubber, but it is elastic. A spring is a steel and it is elastic. So when I brought a steel spoon and a rubber band, there was a reason why I brought both of them together. Looking at this spring, the spring is made up of steel, so it can stretch, it can be compressed, and it will still regain back the normal position, the normal size, the normal shape of the spring. So if this is the normal shape, we call this the normal shape. Now this is the stretched. Let me use another ink. I'll call this the what? The stretched. These have been stretched by what? By either compressing or stretching. Okay? So if I remove the force, this object here, it has a weight. That is why the spring is stretching. If I remove it, it will go back to its normal shape or normal position. I believe you understand now what elasticity is all about, the concept. I believe you understand that now. It has to do with stretching and compressing, not only stretching. It is stretching and what? Compressing. Stretching has to do with this. Compressing is this. So you can compress a spring, you can stretch a spring, and it will gain back its normal size and shape. So the spring is defining the terms elasticity. Is defining the term elasticity. I believe that concept is clear to us. Can we proceed? If yes, give it a thumbs up. So let's go back to the definition that we're considering the other time. If the concept of the elasticity is clear to you, please kindly signify. And if you have questions, drop it in the chat box. And for those following us on YouTube, drop your question in the comments section, and we'll do well to answer your questions. Okay, so we've taken the definition of elasticity. Now I want to give us two definitions of elasticity that you have to pen down. Two definitions of elasticity, and I want you to pen those two definitions down. They are very important. Two definitions of elasticity. Elasticity. Okay, let's take the definition of elasticity. We have two definitions of elasticity. Definition of elasticity. Okay, so this is the definition of elasticity. Elasticity. This is the ability of a substance to regain its original shape. Like I said when I was explaining the concept, to regain its original shape and size after being distorted by an external force. You know, the spring I showed you the other time, there was a force. I told you there's a force that was hanging upon the spring, and that is the weight that was added at the end of the spring. So that is an external force. The spring would have maintained its normal position for long, but since an external force was introduced to the spring, that is why it stretched out. So a device or an element like a spring will maintain its position unless a force is applied. Unless a force is applied. So this is the first definition. The second definition says elasticity is the tendency of a body to oppose a change in its shape or size when force is applied. The tendency of a body to oppose change in its shape. Now, let's take back the picture of the spring because that is where the focus is concerning physics. The focus is on this spring. Okay, so now let's consider this rubber ball. Okay, this is a rubber ball. Now, we all know that this is rubber. The definition we said the tendency of opposing the shape, okay, the force. Because when you are trying to compress a rubber, you are applying a force. Now, what is elasticity? That thing that is opposing the force you are applying to that rubber band or to that rubber ball is called elasticity. The force that is opposing your hand, because you are trying to compress these balls, any of these balls, they are all known as rubber ball. So they have elasticity. They have the property called elasticity. That is, they are all elastic material. They have the property called elasticity. That is, they are all elastic material. So trying to compress that ball, you will see that the ball also will be producing a force that will pushing your hand backward. That force opposing you, opposing your own force is trying to compress it. There's another force that is pushing your hand away. That is elasticity. That is what elasticity. Trying to compress an elastic material, there will be a force that is trying to push you backward. And also when you're trying to stretch, you will get to a moment that you will not be able to stretch anymore. So that's another force that is trying to regain its position. The elastic material is trying to regain its position. That is why you can't stretch more longer. And at that moment, when you can't stretch more longer, in physics, we call it the breaking point. When an elastic material cannot go further than that, when an elastic material cannot be stretched more than that limit, it is called the breaking point. So there's nothing you can do. It will not actually stretch more than expected that you want to do. So let's take a spring. This is a rubber. The spring also has a force. You know, I told you that this represents the force, right? There's always a force that will be reacting against the force that is stretching the spring. That force that wants the spring to gain back its position, that force that wants the spring to be returned back to its normal self, to its normal size, to its normal shape, is called elasticity. It's called what? Elasticity. The force that wants a spring, that wants an elastic material to regain its position, to regain its size and its shape, is called elasticity. So that is the concept behind it. Okay? So that is the concept behind it. Back to the definition that we have. So that is why this definition says it is the tendency of a body. That body has to do with an elastic material to oppose a change in its shape or size. Underline shape or size. Oppose. A force that opposes a change in its shape or what? Or size when a force is applied to it is called elasticity. I believe that is clear. So we have two definitions and two of them are generally accepted. So I want you to take note of these two definitions. Take note of these two definitions. All right. So now let's proceed. This is the definition of elasticity. Now let's consider the difference between an elastic material and a plastic material. But before that, what is an elastic material? What is an elastic material? What is an elastic material? An elastic material, as we have here, an elastic material is one that can regain its original shape and size after the distorting force has been removed. Distorting force is an external force. External force. So what the distorting force causes is deformation of the elastic material. So once you have removed the external force, it will regain back its shape, its size. Okay, so any material that can regain its shape, that can regain its size after the external force, which is known as the distorting force is removed, is said to be an elastic material. And a good example of it we mentioned the other time, we have the rubber band, we have the rubber ball, we have the spring, we have the waistband. So all these are what? Elastic material. We have so many of them. We have so many of them. We have the hand scrunchies used by the ladies. Is also an elastic material. So all these are things that we don't need to think about. Just look around you. What are the things that have these components? What are the things that have this property of elastic? And you can mention as many as you can. So far you understand the concept that an elastic material is any material that can regain its original shape, its original size after a distorting force, in brackets, external force has been removed. When the external force has been removed and it gained back its position or its shape, that particular material is classified to be an elastic material. There's a difference between elasticity and plasticity. Elasticity taken from the word elastic, plasticity taken from the word plastic. Now we need to differentiate them. Okay, let's differentiate between elasticity and plasticity. Elasticity and plasticity. Permit me to clean the board so we have more space to write. Elasticity and plasticity, that is what we want to consider now. What is the difference? We need to get the difference between both terminologies. What is an elastic material? What is elasticity and plasticity? Okay, now let's consider that. Elasticity and plasticity. Now take note that the difference between elasticity and plasticity, these are CBT questions in JAMB. Elasticity is the ability of a material to return to its normal or original shape. So ability to return to original shape when force is removed is called elasticity. Elasticity. Okay? Now, what about plasticity? What is plasticity? Plasticity is the property of a material to remain permanent. To remain permanent. Property of a material to remain permanent. Permanent. Deformed after force has been removed. So when you apply force to a material, and after you have removed the force, the material remains like that. The material cannot actually regain back its own shape or size. Such material is classified to be a plastic. A plastic, a plastic material is a material that cannot regain its original shape after the destructive force, which is the original force or which is the external force, has been removed. It remains like that. So let's say this object I'm doing, this light pen is a plastic. It's a plastic. So it can't, if I actually apply force to stretch it and it stretch, it will remain like that. It cannot come back to its original position. So we have so many example of plastic that we can make mention of, and some of them are very closer to us. Let's take some here. Plastic materials. These ones do not regain back their positions. Now, look at all these that we have here. They are all plastic. This is a plastic. This is a plastic. If I compress this bucket, if I compress it, it's going to deform. And when I remove my hand, I'm no more applying force. I'm expecting it to come back to its shape, but it will not. It will remain like that. It's because it's a plastic. But if it is an elastic, it will come back to its position again. It will come back to its shape again. So all of these examples that we have here, these are more related to our house. We have the dustpan, we have the laundry box. We have so many things there that we are related with. All these are plastic material. That is when you compress it or when you stretch it, it will remain like that. It will not go back to its original shape anymore. So it will be deformed permanently. It will be deformed permanently. That means elasticity. Let's take this note down. That means elasticity let's take this note down. Elasticity is deformed temporarily because it's going to gain back its position. But plastic plastic plasticity is deformed permanently is deformed permanently. And this is a UTME question. That elastic has dash type of deformation: A, temporal; B, permanent; C, neutral; D, none of the above. What should be your answer? Your answer should be temporal, because it's going to regain back its position, so it's temporal. But a plastic is permanent. It can never go back to its original shape or size. I believe the difference between plasticity and elasticity is clear to us now. If yes, please, let's kindly signify. And if you have questions, drop it in the chat box. Drop it in the chat box. We are going to attend to it together. And if you are online, you are watching us on YouTube, if you have questions concerning this, do well to drop your question in the comment section. Do well to drop your question in the comment section. Can we proceed now to the next? Can we proceed to the next? If yes, please kindly signify with a thumbs up. Kindly signify with a thumbs up. Now we want to consider what we call Hooke's law. Hooke's law. Hooke's law. That is what we want to consider next. Hooke's law. That law was actually propagated by the man called a scientist called Hooke. The name of the scientist, permit me to wipe the board. I said we are going to consider now the Hooke's law. The Hooke's law. Hooke's law. Now, what is Hooke's law actually stating? As the name implies, the Hooke's law, the person that propagated this particular law is called Hooke. So it's just like naming the person, naming the law after the name of the person. That is what most scientists do. They give the name given to a law is actually the name of the scientist, Hooke. So now, because he had a law that was generally accepted, it is now named the Hooke's law. So if peradventure anybody has the name Peter, and there's a law that he actually propagated and it was accepted generally by all scientists, then we are going to have something like Peter's rule or Peter's law. So because it is named by the name, it is the name of the law will be given according to the name of the scientist that brought about the existence of that law. So we are talking about Hooke's law, and Hooke's law has to do with elasticity, and we are having this diagram or this picture to explain the Hooke's law. Now, the Hooke's law has to do with states that the force F needed to extend. That is, if there's no force, there will not be an extension in an elastic material. Force is needed before we can experience an extension. No force, no extension. If there is force, there's extension. So state that the force F is needed to extend or compress a spring. So his law was basically focusing on spring. It was not focusing on rubber materials. It was focusing on spring, because in physics, when we talk about elasticity, the major material we take a look at is the spring. And that is why this scientist's law was more focused on the spring. So he said that the force needed to extend. Take note of the word extend. The force needed, that's the key word. To extend, that is another word. Or compress. A what? A spring. So what we have here is a spring. This is called a spring. Okay? A spring by some distance x is proportional to that distance. Force equals to constant factor which is the spring stiffness times what? Distance. Force is proportional to x. That x here, that x represents the what? The distance. Force, the force needed to compress or the force needed to extend a spring is proportional, directly proportional, varies directly to the distance x. And this is the distance x, which means the force needed, this is the normal length of the spring, the force needed to extend it to this place, because from here to here, there's an extension. So x, that x represents the distance from the normal length, from the last normal length of the spring to the new length. So that is why we identify it as what? X. So the distance at which it has stretched, the distance at which it has compressed is called x, is referred to as x. Now look at this one now. From here to here, we have an extension, and now it is times 2 of what we have here. Times 2 of the distance we have here. So if f is directly proportional to x, introducing the constant k, f will be equals to kx, where k is a constant and f is force and e is what? Or x is what? The extension. Where k is the constant, f is the force, and x is what? The extension. The extension in the what? In the spring. So that is the law of what? The law of Hooke's. It says that the force needed to compress or to extend a spring is directly proportional to the distance. Is directly proportional to the distance. Now let's express that mathematically here. Hooke's law states that F is directly proportional to X. F is force needed to extend or compress a what? A spring. And X here is the distance after the force has been applied to the spring. So mathematically, it is F equals to kx, where k is a constant, where k is what? A constant. And k is measured in Newton per meter. Newton per meter. Because your force is measured in Newton and your distance is measured in meter. So the k will be Newton per meter, because if I make k subject of the formula here, I'm going to have divide both sides by x, that is f over x equals to kx over x. If x cancel x, k now equals to force over x. Force is measured in Newton and x is measured in meter. So that will give us Newton per meter. So the unit of the constant is Newton per meter. Newton per meter. So this is the mathematical expression of Hooke's law. And we are going to solve a question on it, how to apply this law to a problem, to solve a problem under the topic elasticity. Under the topic elasticity. Okay? Let's take one question under Hooke's law. Let's take a question under Hooke's law. If you are following me, please thumbs up. And if you have written what I have on the board, thumbs up. Or take a screenshot and let's move to solving a question under the Hooke's law. Solving a question under the Hooke's law. Expecting your reaction so we can take the question in and start solving. a question under Hooke's law. We want to consider a question under Hooke's law. Okay, thank you, Bukola, for your reactions. So I believe we can proceed. We can proceed with solving a question under the Hooke's law. Okay, thanks for your responses. Let's take the question under Hooke's law. Permit me to wipe the board. Solving question under the Hooke's law. So we're going to solve this question under Hooke's law. Calculation on Hooke's law. A load, okay? A load. A load of 5 Newton. When you hear the word load, is force, okay? Force is measured in Newton. You should know that force is measured in Newton. So the load is talking about the force. So F1, that's the first force we had, is 550 Newton attached to a free end of a spiral spring, stretches it from this value to this value, stretches it from this value to this value. So we have L, that is original length, L1, new length, L, original length, this is original. The original length, and this is the new length. So the original length is 0.30 meter, and the new length, it was stretched to 0.36 meter. So after the force of 50 Newton has been added to the spring, it stretched from 0.30 to 0.36. There was an extension. There was an extension. Okay, we have written that. Calculate the length of 70 Newton if suspended from the end. If suspended from the end. So we want to get the length when the force 70 Newton is applied. When the force 70 Newton is applied. So let's solve this question. We need to get E1, that is extension, and that's going to be the new length L1 minus the original length L, which is 0.36 meter minus 0.30 meter, and that will give us 0.06 meter. So the extension is what? 0.06 meter. The extension is 0.06 meter. Now, let's proceed. The general formula is F equals to Kx, but I'm not going to use X this time around because I want to use X to be extension E. X is distance and it's the same thing as extension. So I will say F equals to Ke. Now, for the first one, we have F1, E1. But K is a constant, which we do not know. We need to solve to get the value of K by substituting the force and substituting the what? The extension. Substituting the force and substituting the extension. So we have 50 equals to K into bracket 0.06 close bracket. That is 50 equals to 0.06 K. Dividing both sides by 0.06, we have K equals to 50 over 0.06. And when you divide this, you should be having 833.33 in two decimal place Newton per meter, because 50 is force and 0.06 is a meter. So we have the constant to be 833.33 Newton per meter. Newton per meter. Now that we have gotten the value of K, we can solve for this question. When F2, we have two forces. The first one is F1. The second one is F2. When F2 equals to 70 Newton, the question says calculate the length. Calculate what? The length. They want us to get the length, that is the extension, E2. E2, which is what? The length. Calculate the extension. When they added 70 Newton, it's going to stretch the more. So they want to know what is the extension. They want to know what is the extension. E2, knowing the extension, we'll be able to get the length. So E2, which is representing the extension, when we had 70 Newton. Let's solve that. We have gotten K already. If F2, the general formula, equals to KE2. KE2. But I don't know the value of K, is unknown, question mark. So I'm going to use E2, making E2 subject of the formula so I can get it easily. So if E2 is the subject of the formula, I'm going to say E2 equals to F2 divided by K. E2, which is the extension, equals to F2. F2 is 70. So we have 70 over K. The value of K is 833.33. E2. Dividing 70 by 833.33, we are going to have 0.084. 0.80, 0.084 meter. 0.084 meter. That's the extension. Now the length. How do we get the length? Because the question says find the length. Length, which is what? L2, the new length, question mark. Take note that extension 2 is equals to L2 minus original. Minus what? Original. So we need to know what is the original length. The original length is L, which is 0.30. So extension 2, making L2 subject of the formula. If I take this L2, I bring it to the other side, or better still, take this minus L and bring it to this part. We have E2 plus L equals to L2. Equals to L2. So E2 is what? E2 has been solved to be 0.084 meter plus L, which is 0.30, which is equals to L2. Adding the two together, we are going to have the final answer 0.384 meter. So the new length is 0.384 meter. The new length is 0.384 meter. If that is clear to us, please let's signify using a thumbs up. If you have a question, drop your question in the chat box or the comment section on YouTube. If this is clear to us, please thumbs up. Okay, thanks for your reaction. Okay, now back to the question I asked in the beginning of the class. That question that brought about curiosity. Let's go back to it. We make we have a justice done about the question, and we call it a day with another question, which I will want you to drop your response on on the YouTube page using the comment section. So what was the question? I said between a steel spoon and a rubber band, which one is more elastic? That was the question I asked. A steel spoon and a rubber band, a steel spoon, and this is A, and B, a rubber, let's say rubber ball. Here's this rubber ball. Which one is more elastic? Now, elasticity is not what we think it should be. We believe that when something can be compressed easily, when something, an object, a material can be compressed easily, that means it is elastic. Yes, it is elastic. But that does not determine that it is more elastic. Because it can easily compress, it means that it has less elasticity. Now, if it requires a lot of force to compress an object, like the spoon, if you want to bend this spoon, it's a steel spoon. You will be applying many force, like a lot of force before you can bend it. Now, and also the spoon is an elastic, of course. So because it requires a high energy, a high force, a high volume of force to bend it or to stretch it, then we say it is more elastic. It requires higher force to compress or extend. And that makes it to be more elastic. Okay? But the rubber ball, it's easy to compress it. It's easy to stretch it. So this require less force. Therefore, it is not more elastic. It is not more elastic than steel. So because the rubber ball does not require a, a high force to compress or to extend it, it means that it is not more elastic. It is elastic. Both are elastic. The steel spoon is elastic. The rubber ball is also elastic. But the steel spoon or the steel materials require high force. So high force is equals to high elasticity, and low force is equals to low elasticity. So now you can see the difference. That is why the steel iron is more elastic than the rubber ball. I believe I've made justice to that question. If you agree with me and you understand the explanation, thumbs up. I'm going to drop the last question, which we are going to answer in the comment section on the YouTube page. If you agree with me with this explanation, thumbs up. And let's have the last question that I'll be expecting us to give response to in the comment section. If you understand this explanation, if you agree with me about this explanation concerning the steel spoon or the steel materials to be more elastic than the rubber, thumbs up with the explanation I've just done. If you agree with me and you understand it very well, thumbs up. And let's have the last question. I'm waiting for our reactions. And for people following us on YouTube, looking at this question, I will just make justice to. I want you to drop your view about it in the comment section. You can make your findings and drop your views about this question. Between the steel spoon and the rubber ball, which one is more elastic? We need your response. We need your contributions in the comment section on our YouTube page. Okay, to call it a day, we are going to have one more question, and that we are going to give response in the comment section. Okay, now this question is for us to solve. Okay, permit me to wipe the board. You can take a screenshot if you have not done that. You can do that now. Permit me to wipe the board now. Now, this is the question that everybody is going to make a research on. Take your time, make your findings, make your research, and drop your response in the comment section on YouTube. Drop your response in the comment section on YouTube. So the question is, which material is most elastic? Which material is most elastic? Is it option A? Is it option B? Is it a steel? Is it gold? Is it diamond? Is it graphite? So go and make your findings and give your response in the comment section on YouTube. Which of these is most elastic? Which of these is most elastic? Drop your response in the comment section on YouTube and back it up with some evidence of your findings. Thank you for your time today. Thank you for those ones that joined online for today's class. We really appreciate your time. Tomorrow is another day. Ensure you make yourself available. Class continues tomorrow. We'll be having English and physics tomorrow. So ensure you are available for tomorrow's class. Ensure you make yourself available and tell your friends to join the live class also. Don't forget, practice make perfection. Make use of the A1 Tutor app to practice the UTME questions. Of course, you have access to the answers and explanation after you are done solving your own. And you have access to detailed video on the A1 Tutor app. Ensure you make use of it very well. And tell your friend to tell a friend to tell a friend that A1 Tutor app is the best app to prepare for your examination. Thank you and bye. See you tomorrow.